Today's daily Go video of the day is maximal score after applying k operations, number 2530. For this problem, we're given a zero index integer array nums and an integer k, and we have a starting score of 0. In one operation, we can choose any index in our array nums, and we can increase our total score by nums of I, or whatever index we chose, and then we will replace our nums of I, or the nums of the index we chose, with nums of I divided by 3 rounded up to the nearest whole number. We want to return the maximum possible score you can attain after applying exactly k operations, and so our ceiling function basically just is the least integer greater than or equal to our value. So in example 1, we could see we have 5 possible operations and there's 5 elements of the same value. So for this, we're just going to take 10 plus 10 plus 10 plus 10 plus 10 to get 50. For example 2, we can see that we have 3 operations and almost 5 different values. Well, 10 is our current greatest value. So we'll first select I is equal to 1 and add 10 to our total. Well, 10 divided by 3 is going to be about 3.333. Round that up, we actually get 4. So then we're going to select I as 1 again because 4 is greater than 3 and it's greater than 1. And we're going to add that to our total score. 4 divided by 3 is going to be about 1.33333. Round that up, that is equal to 2. So now we're going to look for our third and last operation, and we're going to look for the highest element. The highest element now is 3, so we can add 3, and our final score is going to be 10 plus 4 plus 3, which is 17. So for this problem, we're going to be using a priority queue. The reason we're using a priority queue is this is going to allow us to sort all of the numbers in our array by least to greatest, even after applying operations like replacing our numbers. So first thing we want to do is take notice that we're returning a long variable. This is because it would go out of bounds for an integer. So we're going to have a long, this can be our total, and it will start at 0. We're also going to have a priority queue, and it's going to store integers. And we can call this our PQ. That is a new priority queue. Now, we are going to have a custom function for this because typically priority queues go from greatest to least. We want it to go from least to greatest. So we can use collections to reverse that order. So we're going to reverse order. And this is simply going to make it so it sorts from least to greatest. Next, we are going to add all of our integers in nums to our priority queue. Because we're keeping this simple, we're not going to use a minimum heap, which would only keep a k amount of elements in our priority queue. We're just going to use all of the elements. So we're going to do a simple for loop for each integer I in our nums array. We're going to pq dot offer I. In a priority queue, we offer as it needs to sort everything out again. So that's going to add everything to our priority queue, going from least to greatest. Now, we are going to simply pop the k top elements and add those to our total. So, while k is greater than 0, while our k value is greater than 0, we can make a temporary variable. So int temp is going to be equal to our pq.poll. And this is just going to pop whatever's currently at the top of our stack or whatever the greatest number is. So after we pull that value, we can add it to our total. So total is going to plus equal temp. Next, we're going to want to update our value of temp, because again, we want to replace temp with temp rounded after dividing by 3. So we are going to priority queue dot offer math dot ceiling. Ceiling just means rounding up of our value, so temp divided by 3. So math.ceil is going to return a double. So we're going to use 3.0 to convert temp to a double. And because our priority queue is going to take integers, we're going to convert that back to integers by adding this. Simply convert it to an integer. So we're going to pull whatever's at the top, add it to our total, and then offer it back after dividing it by 3 and rounding up. And lastly, we just need to make sure we deduct 1 from our k value each time we iterate through, and we can return our total. So if we run this, it passes all of our test cases, and if we submit it, it passes all solutions. So thank you, and follow for more daily LeetCode solutions.